Hi there. Today we're going to be doing a demonstration on soldering, but before we start we're going to go through some of the equipment that we're going to use and some of the health and safety precautions that we have to take. Okay, so in front of us we have our soldering iron kit. It is adjustable, so you can change the temperature very quickly, and it goes from 200 degrees to 400 degrees. Normal soldering will take place around 300 degrees, and that will ensure that we have a very good soldered joint in our PCB. And part of the kit we have a soldering iron holder, which the soldering iron itself must be put in when not in use. We also have some sponges that we use to clean our solder. This piece of equipment is a desoldering tool, and it's used to remove excess solder from our PCB. In front of us now we have a circuit board holder. This ensures that we can hold the circuit board to make our soldering easier. This incorporates a magnifying glass, which will make it a lot easier to see where we are putting our components. These two tools, we have a pair of engineer's pliers, and we have a set of side cutters. The side cutters are used for cutting the wiring, and the pliers are used for holding where necessary. As you can see, both tools are insulated with PVC coated handles. Next we come to the solder itself. The solder is a mix of lead and rosin. Okay, so here we are. I'm at my workstation. I have everything in front of me. I've got my soldering iron set to 300 degrees C. I'm using the soldering iron with the correct tip. Okay, this is a small thin tip. These are interchangeable. I won't touch it because it is hot, but if you see the screw here, if you undo that screw you can change the tips depending on what you're soldering. Okay, I've got my lab coat on and I have my safety spec tools. I'm going to set up my soldering equipment. I've got a small circuit board in front of me that I'm going to be making a circuit from. Okay, and I've got my solder. So to ensure that I don't waste solder, I'm just going to cut some off. So, and it also makes it much easier to handle if you take a small piece off the roll. When we're soldering, the first thing that we're going to do is we're going to tin the solder iron. Now this is going to make sure that the soldering iron tip, okay, has longevity, okay, so it doesn't get damaged and it actually solders nicely. If you have a close look, you'll be able to see that as the solder goes on, it will coat the tip of the soldering iron. Okay, my soldering iron tip is not allowing me to tin it. That is because the soldering iron itself is not clean. So what I'm going to do is I'm going to go away, I'm going to get some emery paper and I'm going to clean the tip. Okay, so here we are, we're back. I've cleaned my soldering iron with some emery paper, and if you can have a look, when I tin the soldering iron, you'll get a thin coating of solder around the iron. It's important when you put the solder on, okay, that you're not over the soldering iron, because as you can see it does let off some fumes. When I clean my soldering iron in my sponge, which I'll show you, okay, the tip of your soldering iron should now be shiny and with a coating of the solder. This will ensure that any components that you're soldering will be clean and you'll have a good soldered joint. So the component we're going to be soldering today in the demonstration is a light emitting diode. It has polarity, so you have a positive and a negative side of your LED. The positive side of the LED is the longer of the two legs. This is called the anode, and the short leg, the cathode, will go to ground or the zero on your circuit board. When we are putting our component into our circuit board, okay, first we must look to see where it's going to be placed and ensure that we get the polarity around the correct way. Sometimes it will be difficult to start and you may have to clean the holes out in the circuit board that you've been given, but I should just about manage this. Okay, so what we do is once we have got our component in place and we have it at the correct height that we want it to be, we just slightly splay our legs on our component and then we place it into the holder, and then we can start soldering. It's important that when we solder, once again, we have all the equipment ready to hand. So I've got my solder, I've got my soldering iron holder, it's at the correct temperature. And I have set the soldering iron to 300 degrees C. I've already tinned it once, but I'm just going to tin it again. Okay, if it doesn't tin, clean it off. And if you can see that, the soldering iron tip is now coated nicely with some solder. When we solder, it's important that you get onto the circuit board and onto the component so that both are at the same temperature, so that when the solder goes into the soldered joint, okay, it goes all the way through and it penetrates, making a good circuit. I will show you a good soldered joint and then I will do a bad soldered joint so that you can see. Okay, I'm just going to zoom in a minute so that you can see the joints that I've done. Okay, well, I can't zoom in close enough for you to actually see, so I'll show you on the board what a proper solder joint looks like. And the two solder joints I've done on the LED, they are very similar to what I'm going to show you, so if you just bear with me a second. Okay, so here we have it. I'm just going to draw my circuit board as if I'm looking at its side view, okay, and I have my little LED and my two legs going through my circuit board. Now, you'll know if you've got a good soldered joint if there is a convex shape at the point of joining. A poor soldered joint will normally consist of a blob of solder And what generally happens there is the solder will not penetrate through and go onto the circuit board itself. It will just lay on top, and therefore you will not get good contact, which means that your circuit more than likely won't operate. So once again, here we are. I've soldered my LED in place. Okay, I have ensured that my solder has penetrated all the way through and onto my circuit board. I would then trim the end of my component to neaten my circuit board up. And then I would go on, continue and solder the rest of my components on. I will do this and then demonstrate the end product and show you what my little circuit board will do. Okay, so here we have our finished product, all soldered nicely and operating. If I put the battery into the battery holder, I will show you in operation. And basically what the circuit is doing is using the resistance through our body to create a circuit which will turn the buzzer on and illuminate the lamp. Okay, so we've done our soldering, we've got our circuit working, but not finished, because obviously if we have made this mess, we have to tidy it away. And make sure all the equipment goes back to where it should go, so that when we want to use it next time round, it is available.